You're welcome to today's class, and today we'll be talking about how to determine the isomers that an organic compound have. So firstly, what is an isomer? An isomer, or let's call it isomerism. What's isomerism? So isomerism is the existence of different structural arrangements of an organic compound. Yes, so it is possible where an organic compound has different the same molecular formula but different structural formulas. So I repeat, what is isomerism? Isomerism is the existence of a carbon compound in the same molecular formula but different structural formula. That means they might be written in the same method, like maybe C3H80, C2H50H, whatever it is, but when it is now time to draw them structurally in terms of their arrangement or when they are to be represented, it becomes different. So how do you determine the number of isomers? Now, the number of isomers, some people just feel it can be gotten by means of drawing it one by one, but there is a trick. There is a way you can actually carry out this calculation easily. You can do it easily with those formulas. Now, I'm going to give you for alkanes, alkenes, and alkynes. Alkanes, and alkynes. So please, I need you to pay attention and I need you to stay put, because at the end of the video you will have the ability to carry out these calculations. Now, first thing is, let's start with alkanes. For alkanes, if you have to carry out for that of alkanes, how would you do that? The formula 2 raised to power n minus 4 plus 1 is what is actually used. But this is applicable for alkanes with carbon atom of ranging from 1 to 7. That is where this is applicable. Now, need I say this? When it comes to alkanes from number 1 to 7, the ones that actually have isomers start from carbon number 4. So that means from number 1 to 3, which is methane, ethane, and propane, they just have one isomer. They can just be arranged in one way. That's it. It can't be arranged in diverse ways. It's just one way. But those that where the isomerism starts coming from, the number will be from 4, which is butane. Remember, methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, and decane. These are the first 10. So if you are going to start with butane, which is carbon number 4, how do we carry out, or how do we determine the number of isomers it possesses? So let's start. Remember that this number here, n, stands for the number of carbon atom. So if I want to determine for butane, which is carbon number 4, what are we going to do? You are going to insert it inside here. You have 2 raised to power 4 minus 4 plus 1, and this is going to give you 2 raised to power 0 plus 1, and 2 raised to power 0 is still 1, so you have 1 plus 1, which is 2. So for butane will have 2 isomers. But if you want to actually talk about pentane, which is number 5, if you're going to talk about pentane, you have it as 2 raised to power 5 minus 4 plus 1, and that will be 2 raised to power 1, because 5 minus 4 is 1, and plus 1, so that means 2 raised to power 1, which is still 2, so 2 plus 1 is 3. So that means pentane actually possesses 3 isomers. But if you move forward and talk about hexane, for hexane, which is 2 raised to power 6 minus 4 plus 1, and you're going to have this as 2 raised to power 2 plus 1. So 2 raised to power 2 is actually 4, so that means you have 4 plus 1. So the answer to this is 5. The answer to this is 5. So that means for hexane, it actually has 5 isomers. So as I said, you can just keep going, and as you just keep inserting the numbers in your end, and you get your answer. But when you now get to octane, when you get to octane, how do you carry out your calculations? How do you determine the number of isomers that is present here? How you carry out the number of isomers is you work with the formula. 2 raised to power n minus 4 plus 2. Now, this particular one is for octane, particularly for octane. So if I want to work for octane, I have the formula 2 raised to power 8 minus 4 plus 2. And 8 minus 4 is actually what? 4. So you have it as 2 raised to power 4 plus 2. Now, 2 raised to power 4 is what? So you have 2 times 2, 4 times 2, 8, and 8 times 2 is 16. So that means 16 plus 2 is 18. That means in this case, octane would have 18 isomers. 18 isomers. Now, if I wanted to do for nonane, the formula is 2 raised to power n minus 4 plus 3. This is for nonane. And for nonane, that means if I want to carry out my formula, the number of isomers, how do I carry it out? You have it as 2 raised to power 9 minus 4 plus 3. And 9 minus 4 is actually 5, so you have it as 2 raised to power 5 plus 3. And 2 raised to power 5 is actually 32. So this is the same as writing 32 plus 3, which is 35. 35. So that means nonane actually has 35 isomers. Now, let's talk about, for alkanes, let's wrap it up with the formulas for octane. Now, if it is for octane, you have 2 raised to power n minus 4 plus 1 plus n. Now, this is for decaying. This is for decaying, which is carbon number 10. Carbon number 10. So that means you have it as 2 raised to power 10 minus 4 plus 1 plus n. And this would give, and our n in this case happens to be what? 10. So now, when you have this as 2 raised to power 6 plus 1 plus 10. And if this is calculated, 2 raised to power 6 is actually 64. So you have this as 64 plus 1 plus 10, and in total you have it as 75. So that means the number of isomers you would find in decane with carbon number 10 is actually 75. 75 isomers. 75 isomers. Now, we have spoken about this. Let's talk about how to determine the number of isomers that is present in an alkene. Numbers of isomers present in an alkene. So stay with me. Now, let's talk about how to carry out or determine the number of isomers that is present in an alkene compound. The number of isomers that is present in an alkene compound. How do you carry out the calculations? Is there a trick way to determine this, or are you just going to draw it? No, you're going to work with two formulas dependent on the number of carbon atoms available. So if your carbon atom is actually an even number, there is a formula to work with it, and if it is an odd number, there is a formula to work with it. For, let's say, if it is an alkene with even number of carbon atoms, what's the formula you're going to work with? 2 raised to power n 2 raised to power n minus 2 plus 1. 2 raised to power n minus 2 plus 1. Now, this is for alkenes with even number of carbon atoms, but alkenes with odd number of carbon atom, what formula are you going to work with? It is 2 raised to power n minus 2, and that's where it stops. 2 raised to power n minus 2. But for this one, which is an even number, 2 raised to power n minus 2. Now let's just insert some figures so it makes sense to you. So let's start with an even numbers. So let's say I'm talking about but, that is butane. That means it has carbon number 4. Carbon number 4. So how are we going to carry out this calculation? You have it as 2 raised to power 4, because our n here happens to be 4. 4 minus 2 plus 1. So that means you have it as 2 raised to power 2 plus 1, and that is 5. So that means butane actually has the number 5 as its isomers. The number of isomers that can be gotten from butane is actually 5. Now, when you come to alkenes with carbon odd number of carbon atoms, you have it as let's say we are going to work with pent, that's pentene. So pentene is actually number 5. So you have it as 2 raised to power 5 minus 2, and this would give you 2 raised to power 3, and that means the number of isomers that can be generated from pentene is actually 8. 8 is the number that you would actually generate as the number of isomers present here. So by reason of this is how to carry out calculations on isomers, number of isomers present in an organic compound as regards alkene. So let's now talk about that of alkynes. How do we carry out the calculations? How do we determine the number of isomers present in an alkyne? So stay with me as I carry out that calculations too. Now, let us talk about how to find the number of isomers, that an alkyne compound has. So how do you determine it? Are you still going to draw it one by one, or is there a formula to work with it? Yes, there is a formula to work with it. So what's the formula? So if the number of carbon atoms present in the organic compound is odd or even, then there is a different formula and approach to work with it. So let's say we have the carbon atom to have an even number. So what's the formula you're working with? You're working with formula 2 raised to power n minus open bracket 2n minus 1 and close the bracket. Now this is for alkyne with carbon atoms with even number. So I'm talking about 4, 6, 8, and all the rest. But if you are talking about alkynes with carbon atoms with odd numbers, you're going to work with 2 raised to power n minus 2n. Now this is for odd numbers. Remember, this is for alkynes. So let's say we wanted to talk about, hexane, for example. Hexane, maybe hexane, hex2i, but we are talking about carbon atom 6. If you are talking of carbon atom 6, now let's try. So if you are talking about hexane, which is 6, carbon 6, what's the formula? 2 raised to power 6 minus open bracket 2 times 6 minus 1, close the bracket. So by reason of this, 2 raised to power 6, what will that give us? 2 times 2, 4, 4 times 2, 8, 8 times 2, 16, 16 times 2, 32, and 10. 2 times 6, 12, and 12 minus 1 is 11. So you have 11, and you close the bracket. Now, when you multiply and when you open this is going to be 64 minus 11, and that gives you 53. Now, but if you wanted to deal with something that has an odd number, a carbon atom with an odd number, so what are we going to work with? We are working with this one here. 2 raised to power n minus 2 times n. And if you are dealing with, for example, pentane, That's you're dealing with 5, carbon atom 5. You have 2 raised to power 5 minus 2 times 5, and 2 raised to power 5 is 32. So you have this as 32 minus 2 times 5, which is 10. So in total, 22 isomers can be gotten from an alkyne with 5 carbon atoms. So this is actually how to carry out the calculations as regards isomers. And I hope by reason of watching this video, you have learned something new. So I hope since you've learned something new, I am appealing to you that you know, like, subscribe, and share this to any individual who you think might need this information. I am going to be dishing out content like this continually to educate minds, and please like and subscribe to the video. Thank you very much.